In this lesson, we'll expand a little more on vertical motion and talk about objects that are thrown. Our student learning objectives for this lesson: apply what we know about vertical motion to model thrown objects. Essential questions: what is special about thrown objects and how can we model it? And below, you see the Common Core standards. Now, instead of an object being dropped or just being dropped or falling, we will look at an object with an initial velocity. This will include our middle term. So instead of putting a big zero there and that term disappearing, now there's going to be a constant there. So now problems are going to be a little more difficult to find, the answers for. But that's why we studied factoring and finding zeros. So an object will either have a positive or negative initial velocity. If the object is thrown up or launched up or somebody jumps up into the air, then the initial velocity is positive. If the object is thrown down or somebody throws something down at the ground or jumps straight down off a cliff or something like that, the initial velocity is negative. Now, there's many different things that a problem could ask you. It could either ask you for the height of an object at a certain time, and that's what this problem does. Let's look at it. If Leslie, standing on top of a cliff, throws a rock upwards at 15 feet per second. So when you see feet per second or meters per second, that's your clue. That's your initial velocity. So throws a rock upwards at 15 feet per second from an initial height of 50 feet. So it starts at 50 feet. So remember that, an initial height of 50 feet. We can find the height of the rock at any given second. And we can find out how long it will take the rock to hit the ground. So first we're going to talk about the height of the rock at any given second. Let's say 2 seconds. We will be substituting 2 in for every t, and we will solve for h. So if we want to find the height, that means we have to leave h alone because that's what we're solving for. So if I have to leave h alone, I should assume that somewhere in the problem it should tell me what I should be putting in for t. Now t stands for time, so if I see, okay, it says 2 seconds, okay, I'm going to put 2 in for t. 2 seconds, that's how long the rock is in the air, and I want to find the height at that time. So if I go down to my second line, first I want to substitute in my coefficients. My initial velocity, like I said, 15 feet per second. So she's throwing the rock up, so therefore it's a positive initial velocity. And the initial height, or the starting height, or h sub 0, is 50 feet. From there, I'm going to substitute in 2 seconds for t. Okay. And then if I solve this out, negative 16 times 2 is negative 32. Plus 15 times 2, which is 30. So negative 32 plus 30, that gives me negative 2. And negative 2 plus 50 is 48. So after 2 seconds, 2 seconds exactly after Leslie throws the rock straight up, the rock will be 48 feet off the ground. Now another problem, or another question that could be asked is, find how long something takes to get to an object takes to get to a certain height. Okay, so if it asks how long, that means you're looking for t. That means you're going to leave the t variable alone, and that's what you're going to be solving for. Okay, just like solving for x with a quadratic function, you can use the quadratic formula. Okay, and that means that if it's saying how long will something reach a certain height, it will most likely tell you that height. So now if we want to know how long it takes for the rock to hit the ground, we substitute 0 in for h, because remember, the ground is most usually 0. That is a height of 0. That's your starting point. Okay? And now we're going to solve for t using the quadratic formula. So I'm going to use the same equation that I had right here. this equation. And now instead of substituting 2 in for t, I'm substituting 0 in for h. Okay, so instead of substituting something in for t here, I'm substituting 0 in for h. And just like I would use the quadratic formula to solve for x, I'm going to do that now. I'm solving for t. So if I substitute in my b, my a, and my c, I figure all that out and reduce it as much as possible, and I get t equals 15 plus or minus the square root, or sorry, 5 times the square root of 137 all over 32. And that is its most simplified form. And remember that not all your answers are going to be pretty. And that's all I have for you for this lesson. I hope you enjoyed yourself and learned a few things. Make sure you try your homework assignment. And if you have any questions, feel free to contact me on BBIM or send me a text message or email. And be sure to come to live class and we'll do a couple more examples. Thanks.